Thank you very much, and good morning. So I am a software person by training. I have about a 30-year career. I'm embarrassed to say 30 years in software. I came to consulting fairly recently, in about the last 10 years. I had an opportunity recently to work for 5 years with a company called Innocentive. Innocentive is an innovation company. And Innocentive helped companies to solve problems using social networking techniques and crowdsourcing. And so I'm going to be sharing with you today some of the experience from that and also from general learnings about how companies can drive innovation in today's world. So let's start with this. This is a campfire. Friendly, warm, nice place to sit. Summer evening, toast a marshmallow, have a good conversation. This is a forge. So a forge is also a fire, but a forge is a fire that does work. A forge produces useful materials, and it does that by combining a number of important elements. So a campfire is a nice, warm fire. A forge is a fire that produces value or work. The history of forges really changed the world. If you've studied history, you know there are periods of history based on forge technology. So, for example, the Bronze Age occurred when people learned how to combine copper and tin in a forge to produce a harder, more resilient metal that could hold an edge. So in the upper left, this is actually an image from Mesoamerica around the beginning of the millennium, around 100 AD. And there you see people blowing air into a closed furnace to generate the heat necessary to smelt bronze. Later on, the technology advanced to automate the injection of air into the forge. So you see in the upper right a bellows. So this is from the Middle Ages, when people began first effectively really to smelt iron in large quantities, right? And so the Iron Age actually started very early in history, but it was actually in the Middle Ages when they actually began to be able to smelt iron successfully in very large quantities. Then you know the large industrial forges. And even today, a major change in economy occurred when the electrical forge was developed as a way to be able to reprocess scrap steel. So the small standalone microforge actually changed the economics of the steel industry dramatically. So even today, as the technology of forges advances, it causes significant shifts in economics. Well, today we're also experiencing another dramatic shift based on the development of a new kind of forge. So let's talk about the digital world, and let's talk about the concept of collaborative innovation. So in many companies we see today, there is a great deal of time and energy being spent creating what are typically referred to as enterprise social networks. So this is Facebook for the enterprise. This is your social network, your collaboration tools inside your company, private network. SharePoint from Microsoft is often used as a sort of a proxy for these. And there are many components of these things. So you could say email is a collaborative communication tool. Instant messaging, Yammer, but things like Jive, for example, these platforms that allow you to collaborate internally. These are campfires. They're great places to hang out and talk and have a good conversation. Sometimes they will produce interesting results. But mostly, in my experience, enterprise social networks, unless they are directed in a more specific way, are good places to engage and exchange information, but they don't lead to concrete results. So you have the way that work is done. You have your core products, for example, your product development process that goes from concept through development, productization, commercialization. Well-intentioned people come along and they deploy these collaboration systems, and the hope is that people will come to these systems, that they will do work there, that good things will happen, and that the innovation will bloom around these campfires. There is nothing wrong with this, and good things can happen around campfires. Innovation can happen around campfires. But I'm going to suggest that if you take a more directed approach to your collaboration and your innovation, that you can create forges. And there are many examples of this, and I want to share them with you, and I want to talk to you about the process for thinking about and how you can engage with and take advantage of this concept of the forge. Nothing wrong with campfires. So what are the differences between campfires and forges? Well, in a forge, you don't just let the fuel burn. You drive the fuel. The fuel is concentrated and fed by forced air, so through a bellows. So there is intense heat. It's not just the normal heat of a fire. It's structured, it's contained, right? And most critically, there is the raw material. There is the metal that you are melting in the forge, the object that you are shaping through heat. This is the reason for the work. This is the thing that's being shaped in the forge. And then you have tools. You have hammers and you have anvils that are used to shape this metal. And then you also have catalysts or reagents that allow you to change the characteristic of the metal. So, for example, the way that steel is produced is by introducing reagents or catalysts into the process that remove carbon from the iron to harden the steel, right? So this is why a forge is different from a campfire. Very similarly, in the digital world, the difference between a social network and a digital forge are these same factors. So the organized, self-selected communities that have an interest in the topic that is being focused on by the forge, this drives a level of collaboration, a focused level of collaboration that is different from just conversation. The raw material in a digital forge is the thing around which you collaborate. And this is really the critical concept here. If you take away one thing today, it is this notion that collaboration for a purpose is different than just discussion, right? So the raw material in a digital forge could be an idea that the community is refining. It could be a problem that the community is collaborating to solve, something concrete. Or it could be a design, an actual design of a virtual object, for example, a piece of software code, or a design for a physical object. And in this case, it would be a digital design, a 3D CAD drawing, for example, an engineering drawing in digital form that is being refined and worked in this forge through collaboration. The tools that you have in a digital forge are the collaboration tools that you use. And in many cases, this is not just discussion, although discussion is important. So forums and chat, all important tools, but also collaborative design tools. So the ability actually to annotate or for teams to work and revise and share, for example, an engineering drawing, right? And then you have your catalysts. And the catalysts in digital forges are the leaders in the community. They're the people that are seeking responses, developing these ideas, and providing leadership. So these concepts, essentially, when you add them, when you take your collaboration capability, when you take your campfires and you add focused collaboration, you add specific raw materials around which people can collaborate, you add tools, and you add leadership, you add curators, the catalysts. This is what makes the difference between a campfire and a forge. Why is this important? I loved what Jim Lovell just said. He said the main lesson that he took away from his experience was always, always expect the unexpected. This slide shows the standard deviation of firm market cap across 10 economic sectors. So this is based on US companies, but I think this is a global phenomenon. The red shows where there have been significant disruptions in the market capitalization of the leading firms within those categories. So as you go through time, if you look at 2010, size of your company no longer protects you. Scale as an advantage, much less important than it used to be. Incumbents are being challenged. The world is changing very rapidly, and there are a number of reasons for this. Economic change, technology change. The world is volatile. And so in a volatile world, in a very volatile world, the core skill that you need to survive is adaptability. You must be able to change. And in order to be able to change, you must be able to experiment. So I would come back to, I think many people are familiar with Toyota. Toyota, one of the leading companies in the world, has been for many years. The Toyota production system is a system of experimentation. So just like Jim Lovell talked about, the ability to experiment. So when they discovered the problem on Apollo 13, they had a simulator in Houston that allowed them to experiment with the procedures to determine whether or not they could use the electrical systems to navigate them back. If they hadn't had that simulator, they would not have been able to make the determination of what process to use in order to save that spacecraft. So I will submit that this ability to take advantage of, create, and utilize digital forges today is a survival skill. It's a survival skill because it allows you to build a capability to experiment rapidly, inexpensively, and to use that experimentation to drive an adaptive strategy. Experimenting in the real world, you can do it, but it's very expensive and complex. And I will suggest digital forges, digital experimentation, prototyping in the digital world will never completely replace experimenting in the real world. You will still need to interact with your customers, you'll still need to do surveys and focus groups. But if you compare and contrast these techniques with what you can do in the online space, in the digital space, what you'll see is that these real-world experiments, they're more expensive, they take more time, and they imply more risk. So at a minimum, if you are able to experiment and develop things in much lower cost ways and much faster ways in the digital realm, then when you do go to try things in the real world, you can have much higher confidence that your real-world trials will actually produce good results. So digital forges enable experimentation, and in the best cases, you can develop a virtuous cycle, a self-reinforcing set of characteristics within your company. You generate more ideas, you're able to perform more experiments at lower cost, faster. You lower the cost of failure, you can try more things, and then because you are able to do this rapidly, you are able to predict better. You're able to better to forecast. And that this then allows you to more rapidly scale up and develop the ideas that actually work. And this feeds back into generating more ideas. And over time, this creates a culture of experimentation, right? And that this is really changing the way that people work on a day-to-day basis. So this is an idea that's been around for a while, but what I want to make sure that you take away here is that this is really coming into the mainstream now. And it's coming into the mainstream both in the public square, in terms of forges that you will see out in the online space. It's also becoming mature within companies. So what I want to talk to you about next is examples that you can look at on the outside, actual capabilities you may be able to take advantage of through partnerships or other means, but also really to think about how you can apply these principles and develop forges within your organizations. Because this is also a very critical capability, and many companies are doing this very, very successfully. So what does a forge look like? Well, these have been around for quite a while, actually. So open source software, of course, I think most people here are very familiar with the notion of open source software. Linux was created this way, but today there are many open source forges, and some of them are actually called forges. So SourceForge, for example, is the online community where many, many open source projects live. And having worked at Innocentive, so at Innocentive we built enterprise software. We built enterprise software using all of these tools. We didn't pay for any commercial licensed software. We used MySQL, we used Apache, we used Tomcat. We used all of these open source tools, which are, for most applications, entirely adequate versus paying for Oracle licenses. These digital forges, the open source software communities, have fundamentally changed the economics and the dynamics in the software industry. So this is a well-established principle. These forges are also evolving. So I want to introduce you, if you haven't heard of it, to Topcoder. So Topcoder is a software forge, but it's a next generation software forge. So unlike the SourceForge communities, which are really relatively unstructured, they do have a level of organization, there are rules around committing code. Topcoder is a community that uses a much more structured crowdsourcing technique and process to actually address the full software development lifecycle. Concept, design, architecture, coding, testing. All of those can be done within the Topcoder community and orchestrated with a project manager that comes from the Topcoder community. So you can essentially commission this community of individuals to run a project for you. And the interesting thing here is that each stage of the process is done by a different team of people who are the best of breed, the best practitioners within that particular domain. This may sound counterintuitive to you, and it certainly did to me to a degree. So person that does design, person that does architecture, person that does coding, person that does testing, they may never talk to each other at all. These programs flow through Topcoder sequentially, but you get the best of breed practitioners at each step along the way. There's a community rating system so that you can see who's involved in your project and you can see the feedback that they've gotten from the community on their work. It sounds chaotic. It sounds like it would never work. It actually works incredibly well. So one specific example, this was a test that was run by NASA. No, sorry, this is not the NASA test. This was actually run by Harvard University, and the problem here was a genetic sequencing algorithm problem. This was run through the Topcoder community as a contest, as a coding contest, and the goal was to produce an algorithm essentially for doing genetic resequencing. So what you see, the black triangle is the standard solution, the standard algorithmic solution, which had existed for many years. And there you see how long it took, so 10,000 seconds to produce a certain level of accuracy. The previous best code results were that's the tan square there, which was somewhat faster and somewhat more accurate. Of the 84 solutions submitted by Topcoder, 16 were an improvement over the previous standard. And what you can see there, so the time scale is a log scale, right? So you see it goes up by powers of 10. So actually the best Topcoder solution was more accurate than the standard solution, and it ran 1,000 times faster with no loss of accuracy. It actually improved accuracy. And this took 2 weeks, this process, entire process took 2 weeks end to end, and it cost $6,000. So this is the next evolution of a forge. So it's the application of structured tools to refine that raw material. So the raw material in this case, the ore, the metal that's being shaped, is the algorithm. Right? And the tool is the community providing the heat, and the tools of this collaborative coding, exchanging ideas, and building on each other. So now this same principle is being applied to pretty much anything that can be represented digitally, and most notably, I think, particularly for companies that are in the industrial sector, it is being applied in a very big way to engineering. And I've chosen one example. So GrabCAD is a site which is an example of an emerging class of digital forges based on engineering. It's one example. There are several. This one is pretty mature. And I think it's a good example because it brings together many of the elements that we talk about. So this is the front page of GrabCAD, and here you see 673,554 members have uploaded 220,384 CAD files. Anyone can go to this site and download any one of these CAD files. They're free. The site is free. The files are free. This is an example of a project that was uploaded to GrabCAD by one of its members. It's been downloaded 13,418 times. It's had 136 comments. That's the heat of the community refining it. And this is available not just in this fully rendered form, but in all the specific engineering forms as well. So you can download this, you can bring it into your AutoCAD program, and you could continue to develop it and refine it. This is, again, the metal. It is metal, is a representation of a metal device, but this is the ore that's in the forge. This is the core object which is being refined through the heat of this community. You can share things. So they've provided a tool. This is a sharing tool. Essentially, you can invite anyone, a private group if you wish, to collaborate with you and actually help you to develop and refine your design. This actual design, believe it or not, I actually did this modeling. If I can do it, anybody can do it. And I did it using a very low-cost CAD tool. So you think about engineering, 3D modeling engineering tools. They used to be very expensive. Well, as part of this process, these folks provide the tools as well. So one of the aspects of GrabCAD, if you go on there, you can actually, for about $15 a month, you can get access to a very powerful online digital modeling tool. There are open source digital modeling tools now like Blender that are essentially free that can give you really professional capabilities in modeling. So modeling is wide open. This community is wide open. And this is not just a toy for freelance people or people playing. So this is General Electric. So General Electric has launched on GrabCAD a competition to design essentially the bracket that's used to lift and move aircraft engines. So this was actually just launched a few days ago. So there are 2 phases, $1,000 prize for the first phase, $20,000 for the next phase. And what you see here is the engineering specifications that the General Electric is looking for in this particular bracket. You see the jury on the right side, the people that are actually going to be judging this competition. Most of them from GE and also some people from GrabCAD. And then this is actually in the middle lower here, this where it says elemental bracket. That is one of the early entries. So this contest has been only running for a few days, but already you're seeing designs submitted that look as mature as that. So where did that design come from? It came from this guy, from Flaviano Crespi. So if we look at Flaviano Crespi's credentials on this site, what you'll see is that he's earned a number of badges. He has a score. His profile has been viewed 8,263 times. His models have been downloaded 9,714 times. So this is Flaviano Crespi's resume, basically, right? And this is increasingly happening. So if you talk to the CEO of GrabCAD, he will tell you that one of their very early successes is people that are very talented freelance designers come on this site, they build their reputation, they get feedback on their designs, and they are able to essentially develop their careers through this process. So this is one of the main reasons why people participate in these communities, is to get that feedback and to allow them to develop. Not just freelancers, but also professionals in organizations take advantage of these sites to build their capability. SAP's open source community, their SAP's developer network, the SAP developer network rating, the equivalent of your GrabCAD score on SAP developer network, is a professional currency that can be used if you work for Wipro or Tata or one of the large consultancies, actually to build your reputation and to become a more marketable SAP professional, right? So these communities, the currency that you build by building reputation in these communities is becoming a tradable commodity. Top coder. When you interview at Google, one of the main things that Google will ask you as a programmer is, do you have a top coder rating? Have you participated in top coder? Do you have a top coder rating? That can help you get a job at Google. GrabCAD is not an isolated example. This is the Global Village construction set. So the Global Village construction set was started by a guy who was a physicist by training, but decided that he was interested in farming and the development of social engineering. And so he went to Kansas and started a farm, and he also started a digital forge. And the Global Village construction set is an open source forge that is creating the designs for the 50 machines required to build civilization, including, among them, a tractor. So here's an example of the open source design for the tractor, and that is actually a tractor that was manufactured from the open source design that was developed by this digital forge, the Global Village construction set. And if you look down at the bottom, the equivalent commercial tractor costs about $30,000. This tractor was assembled from $6,000 in parts using this open source design. This is Local Motors. Local Motors is a digital forge for automobiles. They've designed an open source car. They actually have a small factory in Arizona where they manufacture these open source cars. And they have a local forge where people design automotive parts, another digital forge. So why is that interesting? Well, the United States government thought it was interesting, and so through Local Forge, they commissioned a project which was to develop a new mobile assault vehicle. This vehicle was designed and built in 3.5 months. Again, fully open, community-based. Typical manufacturing process, design manufacturing process for a vehicle of this nature would be 10 years. And so you see your quote here from Barack Obama talking about the fact that this could, in fact, change the economy of the way defense contracting is done. This is Thingiverse. Thingiverse is you could call it a hobbyist community, but it's getting more serious all the time. So Thingiverse is a digital forge where people upload things where they can print them out on their MakerBot. So the MakerBot, you may be aware, is a $300 3D printer that you can buy as a kit and assemble, right? So you see all kinds of interesting things on Thingiverse. People upload their projects and share them very openly. So people, given how open Thingiverse was, you could upload anything to Thingiverse. People began to upload designs for things that were somewhat controversial on Thingiverse. So just to give you a sense of the momentum and the power behind these things and the inability to contain this movement. So when people started uploading controversial content to Thingiverse, the people that ran Thingiverse decided that they were going to censor that content. So they deleted certain files that had been uploaded. And as a result of that, a subset of that community broke out and created a subcommunity, a separate community called DefCAD. So DefCAD refers to themselves as the island of misfit objects. This is, these are objects that have been designed that are not allowed on Thingiverse. And most famously, among the objects that have been developed on DefCAD is something you may have heard about, which is this. This is the first open source 3D printable gun. And it works. And it was printed on a $1,800 printer with $25 in plastic. Doesn't last very long, but so they were able to fire 9 shots out of this gun successfully recently. So this is not a phenomenon that's going to go away. It's something that's pretty impossible to contain. 3D printing is also not a toy. I talk to a lot of people in serious manufacturing organizations who think 3D printing is interesting but potentially not compelling. 3D printing is also changing dramatically and very rapidly. So here is Shapeways. You may have heard the Forrester consultant talk about Shapeways yesterday briefly. Shapeways is a site where you take your digital designs that were refined in the forge of GrabCAD, for example, or Thingiverse, and you send them to Shapeways. They print the object and they mail it to you, right? So you see the bracelet that the woman is wearing here. That is a bracelet which was designed on by an independent freelance designer, uploaded to Shapeways, and it can be printed on Shapeways, not just in plastic, but in stainless steel or sterling silver. So here you see down in the lower left, these are the various materials that are supported by Shapeways, and you see the process here. Basically, you upload your files, you click a button, you select the material, and they mail you your object. This is a prosthetic hand. This prosthetic hand was assembled from 46 individually printed parts in titanium. This could not be manufactured any other way other than 3D printing. So the way this works is essentially the machine creates a cloud of vaporized titanium, and the layers are added on by coalescing the titanium using a laser beam driven by the model. So there really is, and if you look at this, this is mesh, it's titanium mesh, and the ductwork to drive the mechanics, the movement of the prosthesis, is embedded in the mesh. Could not be manufactured any other way. These are shapes that are 3D printed out of sugar by a designer in California who uses them as toppings for cakes. These are organic 3D prints of human tissues. So on the upper left, you see blood vessels, microscale blood vessels that are 3D printed. There's a company called Organovo, which is developing human tissues. Their first project is to create a liver using 3D printing of depositing tissues. Here you see a bioprinted aortic heart valve from Cornell, and then this ear is interesting. It's not actually a replacement for your ear. It's actually potentially a bionic ear because essentially it's a combination of materials. So the ear lobe that you see is actually printed with cartilage, which is actually tissue. But it has an antenna in it that could be used to receive radio signals. So what this is demonstrating is an early ability to combine tissues with other physical media to create devices that couldn't be created any other way. So 3D printing, this has been evolving extremely rapidly. So if you connect the dots now, right, you see this ability to gather and refine designs in these digital forges, and you see the ability for these objects, this metal which has been refined in these forges, to be manifest in the real world. This is an incredibly powerful convergence of capabilities that changes your fundamental ability to experiment. Companies are taking advantage of this today. So in many cases, these are still experiments. So they're experimenting with the ability to experiment, but this is accelerating. So we talked about GE and GrabCAD. Quirky is another forge. It's a digital forge that works on consumer products and has actually developed a number of interesting gadgets and consumer products. GE has put a body of their patent portfolio out to the community in Quirky for them to refine. There's a company here in Paris called ICA, which is a crowdsourcing company for marketing program development. Unilever is working with them. Their digital forge, what they forge in their furnace is commercials, commercial campaigns, ideas for advertisements, right? NASA and Syngenta are both working with an Incentive. DARPA working with Local Forge. Lilly works with Topcoder. Many, many companies are experimenting with working with these external forges. But many companies are also building their own internal forges, and I think that this is very important. So if you think about automotive design, one of the canonical artifacts in the automotive design process is this model. And this model, very often, it's made out of clay, for example, right? And clay is malleable. You can change it. So this is a forge. This is an example of a forge. You have these two people here looking at this design from different perspectives. You know, the engineer is saying, this design is great because it'll be very aerodynamic, and the other guy is saying, yeah, but it's going to cost us a fortune to build it. So they can argue about that constructively and forge it into a design which actually will work both from an engineering standpoint and from an aesthetic standpoint, right? So how can you do this? What are the raw materials that you would have in your forges if you were to build forges within your company? They could be any number of things. They could be designs for physical objects. They could be ideas for new products. They could be ideas for marketing campaigns. They could be your business processes, right? So if you were to collaborate around improving your business process so that the ore, the metal in your forge, is the process design itself, and you're collaborating and refining that, again, a powerful capability. So just a couple of examples. Amazon, their entire website is a digital forge. You can comment on and provide feedback on every element of their website, and they continuously run A/B tests. So when you go to Amazon, without knowing it, you will see one version of a page or another, and based on your reaction to that page, they will track that and they will determine which page you like better, and so they are continuously experimenting using their own website as a forge. This is an interesting example, and one that I would really encourage you to take away with you. Syngenta is one of the largest agri-science companies in the world. They do genetic engineering on crops, and they produce fertilizers and pesticides. So they have created a forge, and for them, the metal in their forge are problems. They surface problems from their product development process, and they put them into a collaborative space, a focused collaborative space, where they refine those problems, and then they make a choice about whether to circulate those problems to broadcast them internally to the entire company, where people can collaborate around them, or to publish them externally to an external forge where people can collaborate around them and bring the solutions back. So just one brief number on the internal collaboration front. When they take a problem through this process, they post it on their internal collaboration site to the entire Syngenta audience. So they have 5 research centers across the world, which generally have not talked to each other very effectively. They focus the entire research capability of the company on that problem 70% of the time, 70, so almost 3/4 of the time, they get at least most of an answer to the problem, if not a complete answer. About 40% of the time they get a complete answer. About 70% of the time they get at least a partial answer. And the cost of this is almost zero. So imagine you have an individual working on a problem. They can continue to beat their head against this for some period of time. they can simply use this forge concept. They can ask everyone. So Syngenta has created this forge as a capability for everyone to ask a well-defined question and to get an answer. So this is a forge working in a very pragmatic, very incremental way within the bounds of the company. Private, secure, but very powerful. People participate in these forges for a variety of reasons. Some of them are intrinsic. They like to solve problems. They like to participate. They like the social interaction. Many cases, these forges also use concrete rewards such as currency, prizes, or recognition. But the design of this is something for your company you would want to be thoughtful about because there are many trade-offs. So for each company culture, you would want to design a reward system for experimentation that pulls a number of these different levers. Over time, if you build this capability, you will develop an experimentation culture. And I think that this is kind of the end state, right? You need to recognize that you need an experimental approach to your business because you must always expect the unexpected, right? You need to embrace dissatisfaction. You need people to be thinking about how to improve things, and you need to provide tools and incentives. And so when we talk about tools and incentives to encourage experimentation, think about forges, not campfires. You need to measure them, you need to tolerate failure, and you need to remove the boundaries and the barriers that prevent people from doing this. Very often, culturally, if you think about problem solving, it's not easy in many companies for someone to raise their hand and say, I have a problem, can I have help in solving that problem? So this is a process that takes time, and very often it requires work at the organizational level and the change management level as well. So what to take away? Yep?
I think we need to take a little time just for one question from the audience.
Last slide. Okay. Campfires are nice. Forges are productive. You need to enable experimentation. We talked about the elements that forges need: communities, raw materials, tools, and catalysts. You can use forges that exist, but you should also create your own. C'est tout.
Thank you very much.